Welcome to this video on converting to and from scientific notation. If you have not already, please watch my introduction to scientific notation before watching this video. Let's begin. In this video, we are going to learn to convert from standard notation. Standard notation is just numbers as you have experienced them in life thus far and as you're used to seeing them. So converting from standard notation to scientific notation, and then we're also going to learn to convert from scientific notation back to standard notation. So as you can see, we have this nice little matrix or table here to organize our thoughts. So the first thing that we're going to work with are numbers larger than 1. So if a number in standard notation is larger than 1, then the power of 10 in the scientific notation will have a positive exponent. So let's do some practice with this. Okay, so we're going to be working on this first row here. So we're going to start with 42,000. So if I look at 42,000, first I want to ask myself, well, where is my decimal point right now? Well, the answer is it's right here. This is where my decimal point begins. And in order to convert this and to make it into proper scientific notation, where would my decimal point have to land? Where would it have to be moved to? Well, the answer is that it would have to move here between the 4 and the 2 to satisfy the rules of proper scientific notation. So in order to move the decimal point from where it is to where I need it to be, I would have to move it 1, 2, 3, 4 times. So that's going to give me 4.2 times 10 to the 4th power. And where did I get that 4 from? Well, I got the 4 from the fact that I moved the decimal place 4 spaces. So let's keep going. So right now, where's my decimal point? My decimal point is right here. Where does the decimal point need to land in order for this number to be converted to proper scientific notation? Well, the decimal point would have to land between the 3 and the 6. So let's count the number of spaces we have to move it. 1, 2, 3, 4, 5. So we have 3.65 times 10 to the 5th power. Again, the 5 comes from the fact that we moved the decimal place 5 times. So at this point, you might be starting to get the hang of this. So if that's the case, pause the video, see if you can work the remaining of the examples in this row, and then unpause it to see if you were correct. All right, in the next example, we have a very large number, but again, our decimal point is starting right here. And in order to convert it to proper scientific notation, the decimal point should land between the 3 and the 4. So let's count. This time I'm going to count in groups of 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So in other words, I have to move my decimal point 3 times. Now students often ask me, do I have to write all of the digits? And unfortunately the answer is yes, you have to write all of the non-zero digits unless the directions tell you to round, which in this case we don't have any directions. So we're just going to write all the digits that are not 0. So we have 3.4986 times, if you recall, we moved the decimal point over 10 times, so it's going to be 3.4986 times 10 to the 10th power. Okay, so let's do the next problem. Okay, so we have 9,304,400. So again, our decimal point is starting right here, and it needs to land between the 9 and the 3 in order to be considered in proper scientific notation. So we're moving it over 1, 2, 3, 4, 5, 6 places. So our new number is 9.3044 times 10 to the 6th power. Okay, let's do this next example. So again, our decimal point is starting here, and it needs to land in between the 1 and the 2 in order to be in proper scientific notation. So we're going to move it over 1, 2, 3, 4, 5, 6, 7, 8 places. So our number in scientific notation is 1.23456 times 10 to the 8th power, because again we moved the decimal point over 8 times. Okay, then we have 4 billion. So again, the decimal point is starting here, and where it needs to land is between the 4 and the 0, right there. So we'll count in threes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this becomes 4 times 10 to the 11th power. And that is 400 billion. So let's do this last example. So the decimal point, of course, is going to start here. It needs to land between the 4 and the 0. So let's count how many spaces we need to move it over. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is going to become 4 times 10 to the 11th power. So that is our final answer. So that completes the first row. So at this point, that means that you know how to, So at this point, that means you know how to convert numbers that are larger than 1 from standard notation to scientific notation. Okay? So now let's go to the next column, which is to convert numbers that are smaller than 1. So if a number in standard notation is smaller than 1, the power of 10 in the scientific notation will have a negative exponent. So let's work through some of those examples. So now we're on the second row of this page. So we have 0.02. So our decimal point is starting here. Where does it need to land in order for this number to be in proper scientific notation? Well, it's going to need to land right here in front of the 2, which means we have to move the decimal point over not once but twice. So this is going to be 2 times 10 to the what power? Well, in the previous examples, remember, we had a positive exponent. But look at this number, 0.02 is smaller than 1, right? 2 cents is smaller than $1. So therefore, we have to have a negative exponent. So, and if you don't believe me, you can type in 2 times 10 to the negative second power into your calculator. It should give you 0.02. Or if your calculator naturally converts things to scientific notation, type in 0.02, it will spit out 2 times 10 to the negative second power. Okay? So again, anytime you're working with a number smaller than 1, that means that you're going to see a negative exponent here. If I had 2 times 10 to the second power, right, well, that would really mean 2 times 100 or 200. And I think we can all agree, if I give you $200, that is absolutely not the same as giving you 2 cents. Okay, so just be a little bit vigilant and careful as you go through these problems and watch whether you have a positive or negative exponent, because it makes a huge difference. Okay, let's do the next example. So as you can see, our decimal point is starting here. Where does it need to land in order for this to be in proper scientific notation? So remember, for it to be in proper scientific notation, you can only have 1 digit in front of the decimal point, so it needs to land right here. So if we count, that's 1, 2, 3, 4 spaces. So we rewrite this as 4.32 times 10 to the negative 4th power. Again, this is a negative exponent because this number is less than 1. All right, let's do the next example. Again, as you can see, the decimal point starts here. It needs to land after the 3, to the right of the 3, in order to convert it to proper scientific notation. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces that we have to move the decimal point. So we have 3 times 10 to the negative 9th power. Again, it's a negative exponent because this number is very much smaller than 1. Okay, then we have 0.00051. As you can see, the decimal point is starting right here. It needs to land between the 5 and the 1. So that we can make it be in proper scientific notation. So that's 1, 2, 3, 4 spaces. Okay, so we're going to rewrite it as 5.1 times 10 to the negative 4th power. Okay, if we look at our next example, again, we can see the decimal point starts here. It needs to land between the 5 and the 9. So we have 1, 2, 3, 4, 5, 6 spaces. So this is going to become 5.922 times 10 to the negative 6th power. And again, remember, you have to transcribe all of the non-zero digits unless you are told otherwise in the directions. All right, so now let's look at this very last example, 5.1. So the decimal point is starting right here, and we don't really need to move it, right? In other words, we need to move it 0 times. So if I had to, if somebody forced me to write it in scientific notation, I could write it as 5.1 times 10 to the 0 power. Now, remember, the whole point of scientific notation is that we can express very large or very small numbers concisely, right? Without writing a ton of zeros on our page. So, rewriting 5.1 using scientific notation, I think we can agree this is easier to read than this, right? Reading it in standard notation makes more sense and is fewer pen strokes than writing it in scientific notation. However, just in case someone ever asks you to do this, you can do it because, again, we're not moving the decimal point at all. So you could just write it as 10 to the 0 power. So now we have learned to convert from standard to scientific notation using numbers that are both larger than 1 or also smaller than 1. So now we're going to go in the other direction. We're going to start with a number that's been given to us in scientific notation, and we are going to rewrite it using standard notation. So let's read our rule here. It says, if the power of 10 in the scientific notation has a positive exponent, the number in standard notation will be larger than 1. Conversely, if the power of 10 in the scientific notation has a negative exponent, the number in standard notation will be smaller than 1. Okay, so let's go ahead and do the next row of examples where we have positive exponents and we're converting them to numbers in standard notation which are larger than 1. So our first problem here is 5.1 times 10 to the 4th power. So we're going to write 5.1, okay, and then we want to make this bigger. So if I want to make 5.1 larger, do I have to move the decimal to the right or to the left? What do you think? Well, I think we can agree that if I move my decimal point to the left, that would give me, for example, 0.51 or 0.051, depending on how many times I move it, and that is making it smaller rather than larger. So since we know we need a number that's larger than 1, that means we must be moving the decimal point to the right. So we're moving it 4 times because of this 4 here. So we go 1, 2, 3, 4. Okay, and then all the little spaces that I created, I'm going to put zeros there. Okay, and then this is very important. You still have to rewrite it because if I looked at that, I don't know what that is, right? That's not written clearly. So I'm going to rewrite it as 51,000. Okay, so 5.1 times 10 to the negative 4th, times 10 to the positive 4th power is 51,000 in standard notation. Okay, let's do the next one. Okay, again, at any time, if you feel like you're getting the hang of this, please feel free to pause the video and do the rest of the examples on your own, and then just scroll through the video and make sure you're correct. So this 6 tells us that we have to move the decimal point 1, 2, 3, 4, 5, 6 places. That creates 1, 2, 3, 4 spots for us. So again, we have to, this is not optional, we have to rewrite the number. Okay, and if you remember how commas work, we start at the right and we count over by groups of 3. So 1, 2, 3, 1, 2, 3. And the point of the commas, it's not for computers. If you try to use commas in a calculator in this method, it's probably going to be confused and mark it wrong or give you an error. They're just for human use, right, to visually separate groups of numbers. So now that I put the commas in, I can easily see this is 9,890,000. Okay, so now we have 4.2 times 10 to the 5th power. Okay, so again, we're going to move the decimal point over 5 times. 1, 2, 3, 4, 5. Okay, notice that you can't necessarily rely on the exponent to tell you the exact number of zeros, right? Because you also have a varying number of digits after the decimal point. For example, I have 2 digits here, I have 1 digit here. So you really have to rewrite it and think about it that way. Okay, so again, I have to rewrite this. Okay, and then again, I start at the right, I count groups of 3. So this is going to be 420,000. Okay, so now I have 7.64 times 10 to the 3rd power. So we're going to move our decimal point over 1, 2, 3 places. So this becomes 7,640. You can put a comma there or not. Okay, now I have 5 times 10 to the 2nd power. There is no decimal point here, but remember if there was, right, it would be to the right of the 5. So now we have to move it over 1, 2 spaces, fill those spaces in with zeros. So 5 times 10 to the 2nd power is 500, Try to make that look more like a 5 and less like an S. Okay, and then lastly, we have 6.66 times 10 to the 8th. So we're going to move the decimal point over 1, 2, 3, 4, 5, 6, 7, 8. We're going to fill in all those little spots with zeros. Okay, so we have 6, 6, 6, and then it looks like we have 6 zeros. 1, 2, 3, 4, 5, 6. Okay, so you have 666 million. So that is your answer there. So going back to our little chart, right, we just finished converting from scientific to standard notation using numbers that are larger than 1. Okay, now we're going to look at what happens if we have numbers smaller than 1. In other words, we're given numbers in scientific notation that have negative exponents. So let's look at those examples. So this is our last column here. So we have 6.23 times 10 to the negative 6. So again, sometimes people want to memorize, should I move left or should I move right? And in a minute, I will talk about that more formally. But in general, I find that confusing because it's going to change depending on where you are in that chart. So instead, I ask myself, okay, well, I have a negative exponent, so this has to become smaller than 1. So if I start moving my decimal point this way, is that going to make 6.23 smaller than 1? And the answer is absolutely not. It's going to make it bigger. So obviously I can't move the decimal point in that direction. I must have to move it in the other direction. So we're going to move it 1, 2, 3, 4, 5, 6 units to the left. Okay, and if you would like to, I always do, just to draw attention to my decimal point, I put a leading 0 here. Okay, it's up to you if you want to do that or not. So we have 1, 2, 3, 4, 5 zeros, and then 6, 2, 3. Okay, and that's our final answer. Again, if you do not rewrite it, if you left it like this, you're not going to get points because that's a hot mess and it's confusing to try to understand or grade. Okay, so we have 5.1 times 10 to the negative 4th power. So we have to move it over the decimal over 1, 2, 3, 4 points, 4 spaces. Okay, again, if you'd like, you can put a leading 0 on the other side of the decimal point. I always like to do that to draw attention to the fact that there is a decimal point there and it's not just a mistake or a smudge on my paper. Okay, so you have 0.00051. All right, next one, we have 4.2 times 10 to the negative 1st power. So we're only moving this decimal point over just the 1 space like that. So this becomes 0.42. All right, next one, we have 7.64 times 10 to the negative 3rd. So we're going to move the decimal point over 1, 2, 3 spaces and fill in those extra spots with zeros. Again, you can put a leading 0 there if you'd like to. I always like to put 1 there. So you have 0.00764. Okay. Then we have 3.76 times 10 to the negative 8th power. So we have to move this guy over 1, 2, 3, 4, 5, 6, 7, 8. Kind of ran out of room there. Didn't plan very well. So we have a bunch of zeros there, 7 zeros, and 8 if you count the leading 0. So we have 1, 2, 3, 4, 5, 6, 7, 3, 7, 6. I kind of took up some space in the other box, but you can hopefully still see it, still read it. Okay. All right, and then we have 1 times 10 to the negative 2nd power. So my decimal point is starting here. I have to move it over 1, 2 spaces. Again, you can put that leading 0 there if you want. I always like to have it there. So it becomes 0.01. So I want to talk for a minute why I object to moving the decimal point left or right as a way to remember or help you figure out what you're doing. And so let me just demonstrate really quickly. So when we were converting to scientific notation using numbers that were larger than 1, we moved the decimal point to the left, right? So the decimal point in all of these examples was going left. Then, if we were looking at numbers that were smaller than 1, then we were moving the decimal point to the right. Then, when we were converting to standard notation, if I had a number larger than 1, or in other words, if I had a positive exponent in my scientific notation, right, I was moving my decimal point to the right here, okay? And then, if I had a negative exponent, then I was moving my decimal point to the left, okay? So notice that whether you move your decimal point to the left or the right depends on two different things, right? It depends on whether you're going from standard to scientific, as we are here, right? Or whether you're going from scientific to standard, as we did in the last two examples, or the last two rows, right? But it also depends on if you have a number larger than 1 or smaller than 1, right? So you have 4 different cases, and in each case, right, it depends, it changes whether you're moving it left or right. So again, I find all of that just kind of overwhelming and confusing. So instead of thinking about that and trying to memorize left, right, okay, what I do is I just ask myself, okay, is this number larger than 1 and or does it have a positive exponent, right? If it has a positive exponent, I better end up with a number larger than 1. Conversely, if I start with a number larger than 1, meaning I'm starting in standard notation, I better end up with a number in scientific notation that has a positive exponent, right? That just makes good, plain sense to me, and it's something that I can remember. Okay, conversely, right, I know that if I start in standard notation and I have a number smaller than 1, then I'm going to end up with a negative exponent, because that's just how it works, okay? Likewise, if I start in scientific notation and I start with a negative exponent, right, then my answer should be less than 1, less than $1, okay? So that is how I use, how I remember which way to move the decimal point. So I don't think about if I'm moving it left or I'm moving it right. I'm just wondering, I'm thinking to myself, am I trying to make this larger than 1 or smaller than 1, right? Or again, if it is already larger than 1, I better end up with a positive exponent. Conversely, if it is in standard notation already smaller than 1, then I better end up with a negative exponent.